All right, in section 3.8, number 31, we have this equation, and they want us to give the domain of each function. And again, usually the domain is all real numbers, except if we have a square root with a negative underneath it. Okay, so we have to make sure that what's underneath there is greater than or equal to 0. Or if we have a fraction with a variable on the bottom and there's a way we cannot let the, let's put just denominator here, the denominator can't be equal to 0, okay? So we see we have a fraction, we see we have a variable, we need to check it out. So what we do is this, we take the denominator and set it equal to 0 to see if there's going to be any problem. So let's do that. X squared plus 3 is 0. Well, let me subtract 3 from each side. X squared equal negative 3. Okay. If I square root both sides, the only thing, now when I'm doing this, what I'm doing is I'm trying to find any numbers that will mess my denominator up, okay? I'm going to write that out here. So if there's a number that messes it up, I'll find it when I solve this little equation. Well, I get x equal plus or minus, can use square root, we have to do plus or minus. I get x equal plus or minus the square root of negative 3. If I had plus or minus the square root of negative 3, that would screw this denominator up. Well, that's an imaginary number. We'll learn about it later this year, but it's not even a real number, so we don't have to worry about it. Right now we're going to say, hey, that's not a real number, so there's nothing that messes it up. Nothing messes denominator, nothing makes denominator equal 0, in other words. So our domain is all real numbers. And this is our answer right here. A lot of these, just because I know these are kind of hard for people to wrap their heads around sometime, we'll be doing some different ones in class. In 33, we have f of x is equal to 1 over x squared plus 5x plus 6. Now again, we would usually say our domain, because that's what we're trying to find, the x's that we could plug in, is all real numbers, except if there's a square root that has a negative underneath it. We got to make sure it doesn't get a negative underneath it, in other words, or we got to make sure our denominator can never be equal to 0. So let's look at our denominator. It's x squared plus 5x plus 6. We're going to set it equal to 0 to find any problem numbers. Okay? Well, now, how do I solve that? That's a quadratic equation. I've got choices. I could try to square root, I could try to factor it, I could try to use the quadratic formula, I could complete the square, I could try square rooting. The thing that makes sense here to do is to try to factor. We always want to try to factor first. And honestly, most of the time in your textbooks, they're going to give you things that will factor. Now, if you think about it, we're trying to say what things, and again, I'll do the, just in case you're still having trouble factoring, we're always trying to multiply to get the number on the end, if it's just a plain old x squared like this, and add to get the number in the middle, which we call b, if we were to label it ax squared plus bx plus c, and I'll go ahead and do that just in case some of you are still struggling. Okay, so we're trying to multiply to get that 6, that's our c, and we're trying to add to get 5. Well, 2 times 3 is 6, and 2 plus 3 is 5. So those are our numbers, a positive 2 and a positive 3 that go in our factors. But now we have to remember to use the zero product property. And what that says is if you multiply any two things and you get 0, one or the other of them had to be 0. So we could have had x plus 2 equals 0, or we could have x plus 3 equals 0. All right, to solve for x, I just subtract 2. Oh, x is negative 2 will mess my fraction up and make a 0 in the denominator, so I can't let x be 2 in my domain. I'll have to make sure I don't do that. And then over here, if I'm solving for x and I subtract 3 from both sides, I find out that x equal negative 3 is another number that if we plugged it in, we would get 0 in the denominator. So what I can do is, this is how we usually write it for my domain. We can say my domain is represented by x's, and here's what we say when, if it can be anything except these two numbers, we can write it this way. X just can't be negative 2, and x can't be negative 3. we just draw an equal sign with a line on it through it to show we can't let it equal that. So what this means is it's all real numbers. This actually is telling people when you write it this way, this is all real numbers except -2 and -3 is my domain. Okay, then we're going to look at number 35. 35 is a different type of problem. All right, these are called composite functions, and we can break a lot of functions down and write them as separate functions, and there's something that we do related to this in calculus, which is why your book's covering it. It's not just, oh, let's do this for the fun of it, okay? Let's start with the one on the left, f of g of 1. What this is telling me, I always kind of start from the, well, you could do it either way. I'm going to just start from the inside, okay? I'm just going to write down f of g of 1. So it might help. What this means is I'm going to go do the f function, which is x squared minus 1, okay? But what I'm going to place inside of it, let me do this. If I'm going to do the f function, it's x squared minus 1, okay? But what I'm going to plug in is g of 1. So you kind of start from the outside, I guess is the best way for me to tell you to do it. You start from the outside, you say I'm going to do this f function, x squared minus 1, but what I'm going to plug in it is g of 1. Well, now let's go off to the side. What is g of 1? Well, g of 1, let me come down here a little bit. G of 1 would be take the g function and plug in 1. Remember, that's why we have this notation, so I don't have to say take the g function and plug in 1. It would be a lot of writing. That's what this g of 1 means. So what's the g function? It is 1 minus 2x. And again, what I'm doing instead of rewriting it, since it's up at the top of the page, is everywhere I see an x, or to plug in, I'm putting a parenthesis so that I can go stick in what they're telling me to stick in. And they're telling me to stick in 1 here. So that's 1 minus 2, because 2 times 1 is 2, which is negative 1. So g of 1, which is what this right here is what I'm supposed to stick in right here. I'm sticking in negative 1. Well, what's negative 1 squared? It's 1. And 1 minus 1 is 0. So f of g of 1 is 0. Let's do another one. It kind of takes a minute to get some of this going in your mind sometimes. All right, so now in this function, they're telling me to do the g function. So I'm going to write down 1 minus 2 times x, okay? I'm looking at right up here, and I'm just writing it down. But instead of writing the x there, they want me to plug in f of 1. Now, I could do all this within the parentheses, but I'm trying to kind of show you how to chunk it up to make it a little smoother, okay? So here we go. We need to find out what f of 1 is so we can plug it in. What is f of 1? Well, that means go take the f function, which again, that is x squared minus 1, from up here at the top, the f of x at the top of the page. And they're telling me to stick 1 in because that's what's in the parentheses after the f. So I'm just going to stick the 1 in. That's all that means. It's just a shortcut way of writing it. Well, 1 squared is 1, and 1 minus 1 is 0. Okay? So what is f of 1? F of 1 is 0. Remember, that's what this whole thing is. So what I could write it this way. I could say, well, what's g of 0? Because that's what they're telling me to plug in right here in this, where I had started off writing this g function right here. This 0 is what is going in here, basically, because this right here is actually equal to 0. All right, so that's just 1 minus 2 times 0 is 0. 1 minus 0 is 1. Okay, now we're going to do number 37. One thing I want to point out is that if you look back at 35, we got 2 different answers. So one thing we can see is it's different if it says f of g of something and then g of f of something. We should expect different answers. There's only one time we get the same answer, and we have not talked about that yet, and I'm sure it'll come up eventually, okay? And again, this is going to show up later in the year, so you got to get it now, and if you don't, you need to come get some help, okay, if this video doesn't do it for you. All right. So let's start with the left one. This is telling me I start from the outside and I read in, and again, this is called a composite function. When they put a function inside of a function, it's called a composite function. This is telling me go get the f function. Well, the f function is x squared minus 1. I'm not going to rewrite it. I'm just going to put a parenthesis where the x is. And what they want me to do now is find out Whatever's inside these parentheses here is what I'm going to plug in right here. Well, what's in there? It's g of 2. So let's go off just so we don't have as much mess, okay? Let's go off and find out, well, what is g of 2? Well, that's telling me to go get the g function, which is up here. It's 1 minus 2x. So I'm going to put 1 minus 2 instead of x. I'm going to put parentheses because this 2 in the parentheses is telling me to plug in. Let me do it here. This 2 right here. Did it take? No. This 2 right here is telling me to put a 2 here. Okay, well, I can figure that out. That's 1 minus 2 times 2 is 4. See why you had to know PEMDAS? You're using it all the time, aren't you? 1 minus 4 is negative 3. So g of 2 is actually, this whole thing right here is actually equal to negative 3. That's what I'm going to plug in here. You could do it that way. You could say, well, what's g of 2? It's negative 3. Cross it out. Oh, I'm supposed to find f of negative 3. Or you could just say, take it and plug it in the parentheses, however you want to think. All right. So I plug the negative 3 in. Negative 3 squared is positive 9, not negative 9, right? And subtract 1, that's 8. Okay, so the first part of our answer is 8. Now let's look at the second one over here. We got g of f of 2. That says go get the g function, which is right here. Okay, it's 1 minus 2 times x. And what are we going to place inside for that x right there? We're going to plug in f of 2. Okay, well, let's go again off to the side and go work on it. What is f of 2? F of 2 says take the f function, because that's what's on the outside, tells us what function to take. It's x squared minus 1 from up here at the top, and I'm just going to make a parentheses for the x. And I'm supposed to plug in 2. Okay, so 2 squared is 4. 4 minus 1 is 3. Okay, so 3 is f of 2. So that's what I'm going to put. I'm going to say, oh, well, what is f of 2? F of 2 is just 3. So I'm supposed to put 3 in here. Or I could just say, hey, I went and figured that out. Let's go plug it in now. All right. So what do I have? I have 1 minus 2 times 3 is 6, and that is negative 5. So that's the second part of that answer. Okay, so this one has a couple of twists to it. Nothing hard. You can do it. Okay. So I look at the first one over here, and it tells me to go get the function f. Well, it's x squared minus 1. Well, what am I supposed to put inside of there? What comes next in these parentheses is telling me what I'm supposed to plug in right here. I'm supposed to plug in f of 2. Now, it looks weird because you got 2 f's in a row, I know, but you still just do the same thing as we did on the last problem. You just say, well, what is f of 2? Well, what is the f function? Oh, I look up there. It is x squared minus 1, and this 2 is telling me to put a 2 in here. That's all it means. Well, 2 squared minus 1 is 4 minus 1, which is 3. So what this is really telling me to do is to find f of 3, which means stick 3 in here, or I could have crossed this out and put a 3. 3 squared is 9. 9 minus 1 is 8. Okay? Okay, so sometimes you have stuff like that. Now the one on the other side looks very strange, I know, but it also starts with the f function. So I go, well, okay, what is the f function? It is x squared. I'm just going to write a parenthesis so I can plug in what I need to plug in. X squared minus 1. Well, what am I supposed to plug in? I'm supposed to plug in 2 times f of 1. So let's write that down here. Okay, that looks a little weird, but that just means find f of 1 and multiply it by 2. So let me do this. What is the f function? The f function was, so here's the 2, putting it here. Now I'm going, okay, here's the f of 1. What's the f function? It's x squared minus 1. But inside of that, I'm supposed to plug in 1 in that function. Okay. So let's just add another layer onto the difficulty, didn't it? 1 squared minus 1 is 1. And 1 minus 1 is 0, so 2 times 0 is just 0. So all this mess up here is really just 0, or I could have crossed this out and put a 0 and said, oh, I'm supposed to plug 0 in here. Okay, so 0 squared is 0, minus 1 is negative 1.